Hey everybody, this is Larry, this is me going with Q3 of the weekly contest 365, minimum size subarray in infinite array. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem. So this one was kind of very tricky for me. I ended up taking about 10 minutes, though some of it I was just trying to convince myself that the proof is correct, and you can see that during the live portion of this video. Okay, so I think the first thing to notice, and you may not do it consciously, is that all the inputs are positive, right? Where is it? All the inputs are positive and the target is positive. So what that means is that, and you may already made the assumption without realizing it, is that the numbers are always going to be increasing, meaning that there's no like weird, like a knapsack target sum is equal to 0 type thing, where you have negative numbers and then it becomes way, it can go many each way with a lot more permutations. But once you realize that, then you can break it down into a couple of cases. And for now, I'm going to say, let's say target is a small enough number, right? What happens? Let's solve that problem first, right? So let's say target is a small number, and what is the definition of a small number? It means that it is smaller than the total of nums, so that it has to be within the target is a sum of some numbers here in one, without going over, right? And of course, in this case, though, what you would do is that you would double the array because for example, you have targets equal to 4, then 3 and 1 is the minimal, so you have to be careful about that because you have things that goes over the border, but you can only go over this border once, so that's why doubling the array works. It's a technique that comes up here and there, so definitely something to kind of consider. And then here, then how do you get target is equal to 4 in the minimum, the shortest subarray, right? And that part, I don't want to feel like I'm skipping ahead too much, and I apologize if it sounds that way, but it is a problem that comes up a lot on Leetcode, so definitely something that to get brushed up on is that, given this kind of thing, it is just, you kind of do it in a prefix sum kind of way, right? So I don't quite write the code like this, but you can imagine, okay, let's say you have 2 arrays, and then you just calculate the prefix array. So 1, 2, and I'll just add a 0 from the beginning just for, with the no element, right? So, and just add this so I line them up so it's easier for me. 8, 9, 10, 11, 13, 16, right? So then now you have this prefix sum array, and let's say you're at some number x, you're going from left to right, and then you want to have some subarray that sums to the target, right? So that spoiler alert. So that means that in this case, let's say x is equal to 9. Our current number is equal to 9. That means that you have some x minus some other prefix. I don't know what it is yet, right? Is equal to target, right? Because, and you can think about this as like a segment thing, right? Because now x is some long segment, and then prefix is some smaller segment, and you try to find the target such that target is equal to your given target. And of course, now you have one formula with one variable, so you just have to kind of work it out. You minus prefix on, or you add prefix on both sides, you subtract target on both sides, so then now you have x minus target is equal to prefix, right? You add target, you add prefix on both sides and you subtract target on both sides, right? So yeah, and because this number, so you can just look for this number by, so for example, if this is 9 and this is 4, then now prefix is, you have to find a prefix such that prefix is 5, which we have here. Okay, so we got that. And you're able to find it. So how do we keep track of the last time that happened, right? Well, it turns out for this problem, because again, all the numbers are positive, there's only going to be one case in which this is true, right? There's no zeros, so you don't have to worry about stuff like that. I actually implement it in a way such that it actually doesn't pay attention to this, but it may be helpful. And because of that, then now the length. For example, that what is this index? This is like index 7 or something like this, and this is index 5. That means that the 2 numbers or 3 numbers in between or something like this, right? I'm making numbers up, but you get the point, hopefully. But yeah, so then now, so that part, hopefully we understand this part. This part is, as I said, a lot of the basis of a lot of Leetcode problems. They reuse this pattern a lot. I don't know if it comes up that much during interviews per se, but on Leetcode they do. Okay, so then now you have the big number part, right? So what do I mean by big number? Meaning that target is greater than sum, right? Or total. Let's say total. What does that mean? That means that basically, yeah, because every number is positive, or every input number is positive, you always, if you add a number, you always get a bigger number, right? So that hopefully makes sense. So that also means that there's really, if you have a total, there's only one way to add to the total, right? Meaning that, okay, let's say instead of target 0, 4, you have, I don't know, some big number, right? What does that mean? Well, that means that given that this, I guess sum is 8, right? So now the sum is 8. That means that you basically have to loop over a lot of things, right? So let's just say sum, and then now something like this, right? Dot dot dot, right? Well, I'll just start it off the beginning, I guess. And here the idea is that there's really, I mean, and if target is bigger than sum, you always have to use one loop per, or at least one loop. The number of loops you have to kind of do the math, and we'll do it later. But right, because for example, and there are multiple ways to kind of do this. For example, you can consider this a loop. The 23111 is a loop because it's kind of the original input but phrased another way, so that if your yeah, right. So if your target is for this problem, if it's, I don't know, 11, oops, then you may have 1 plus 2 plus 3, like all the way to here, but you still have to go through one loop once, no matter how you do it, because that's just it's almost like a pigeonhole thing, because there's no way to get that number without skipping it, because it repeats itself, right? And of course, there are other ways to do it as well, possibly. For example, if you do something like this, and then now it's just this sum plus 3, right? So that's obviously even smaller, but these are kind of the things that you're thinking about. So the idea here is that now, and because this target can be big, you can't really simulate this. You have to be really careful and just do the math. And this is where we will go over the code. So given n, we have total is equal to sum. This is just infinite sentinel values. And then the loops is just, the number of targets that this can do, right? And then target, after that we mod the total, because that's the remainder, right? That's the remainder of the total loops. If the target is equal to 0, that means that the loops are perfectly, similar to it. So then now you just need, there's the number of loops, there's the number of numbers per loop. So then it's just loops times n, right? And yeah. And then the rest, excuse me, I got a little bit of allergies going for some reason. But yeah, and then the rest is just what I said with the DP. We double the array, we do the DP, and we kind of calculate, we store the index whenever we see the prefix, and then we also keep track of the smallest of the target thing that we talked about. And at the end, if it's not possible, we return -1. Otherwise, we return the best plus the loops, the number of loops times n, right? And that's pretty much it. So this is linear time, linear space because of the DP. So yeah, that's all I have for this one. Let me know what you think. It's really tricky, for sure, and a lot of things you have to kind of prove to yourself that is correct. At least for me, that's why it took a long time. So yeah, let me know what you think, and you can watch me solve a live in contest now. I was a little bit lazy. Like, even though I was thinking about it, I wasn't careful about it. Like, poop. All right. I'm not reading this. Okay. One, two. It should have been indexed. This is way confusing given that that's a subarray. But okay, fine. Okay. Target. Okay, so there can be all ones, and then you have a target of 10 to the 9, so the number can be 10 to the 9. Okay. So, okay. I think you can do a per element thing, but it's definitely tricky to get right. Should be just DP, but or maybe not. I don't know. Two pointers. So many ways to do it, and they're all kind of weird. I got a silly mistake on Q2, so. I think you just have to roll it twice, but one target. Okay, I see. So loops is equal to target total. Right. Okay, so now you can just do 2 of these, right? Okay. Yeah, okay. Okay, yeah, okay. Well, wait, we want target, so if current minus some previous number, okay, so equals target, and current minus target, okay. SNDP. Return. Oh, that's not true. We want to DP current minus target. Maybe +1. Yeah. Well, I have to at least get this right first. Well, that's fine because this 3 is, I think D is 3. I'm going to run it again. Okay, and then now maybe, oh yeah, of course I totally forgot about the loops. Times n, right? So let's say you have that's just not right. Target. All right, good thing you test this, Larry, because that is a bit, don't know what happened here, but so 1 is 0, that's fine. 2 is 1. So 2 minus, and then target, what's target? Target is 0. Target is 0. Is target ever 0? Target is never 0, so I guess if target is 0. I mean, that's right, but I don't want that. I mean, I want that, but I want a tougher one as well. 667, is that right? Sounds right, actually. Alright, let's give it some minute. It's probably not right, but okay. Silly mistake on Q2. Alright, let's. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.